Okay, Algebra, happy Friday. Today's lesson, again, in spirit of you guys doing a review lesson last Tuesday and hopefully continuing that today. It's going to be a pretty mellow end of the week. It's more a lesson that I find interesting and that hopefully you get some interest out of or something from and don't hate totally. It's a melding of algebra and geometry. And the regular Math 8 class is currently doing the Pythagorean theorem. So this is going to relate a little bit to that, and we'll see what that is later. So your warm-up is two things. You want to find the area, hold on, let me write this down over here. I'll put it down here, because we don't need those drawings yet. So the warm-up will be to find the area of a square with side length a plus b. All right, that's the first step. And then the second one is going to be to find the area of the triangle don't count the boxes. So try to remember how to find the area of a triangle. So take a minute, try to do that, and then I will have the answers on the paper when you come back. Okay, so first item on the list, finding the area of the square with side length a plus b. So I just literally drew the square with side length a plus b and treated it like an area diagram like we used before, where I had a squared, ab, and b squared. And then I also just multiplied it out like we have been taught. So distributing twice. So a plus b squared turns into a plus b times a plus b. And then just distributing that to a, and then distributing that b. And already combining like terms, I get this as my result. So that's my area of my square with a side length a plus b. And this triangle is really only confusing because of the a and the b and the c. So the area of a triangle is, remember, just 1/2 of the times base times height. Because base times height would be the rectangle. Like if I had this rectangle, that was a, b. The area of that would be a times b. But the triangle is 1/2 of that. So the triangle needs 1/2 of the area. All right, this is a little geometry refresher. So we're gonna use both those facts today in looking at our cool little Pythagorean theorem thing from 8th grade. Or well, you did it last year, but it's really an 8th grade standard. So we're gonna look at this square right here. Now that square is made up of a bunch of pieces. First we have the black perimeter square. We have like the whole thing. So we have this whole outside square here. And we're gonna see if we can find the area of the big square two different ways. So the first way we find the big area of the big square, and I'm running out of room, area of big square, is what we already did in our warm-up. So we did a plus b squared. Because in this square, my bottom is a plus b, or b plus a, and my side length is a plus b, and all the side lengths are all a plus b or b plus a, which are the same thing. So it's a square with a side length a plus b. So my area is going to be side length squared, or a plus b squared, which again is going to be a plus b times a plus b. And then distributing a squared, a times b is ab, b times a is ab, and then b times b is b squared. All right, and those AB's combine to make 2AB. All right, so now we're gonna look at the square as a couple different pieces. So this square is made up of a whole bunch of different things. The square is made up of 5 little shapes. It's made up of a little triangle here, a little triangle here, and notice all these triangles are the same triangle. It's the same triangle we looked at before. And the areas of those triangles were each, see, it was an A by B triangle. So the area of each triangle was 1/2 AB. So I have how many 1/2 ABs? I have 1, 2, 3, 4. So now I have area. Marker was a terrible, terrible idea. I'm so sorry. So area, I have 4 1/2 ABs. Then what else makes up this square? I got the 4 triangles out of the way. Now all that's left is that piece in the middle. And what shape is that piece in the middle? Well, it looks like a square, and turns out it is. I could prove it's a square, but I don't feel like it, and I don't think you need me to. It looks like a square, right? If I tilt it, it looks like a square. Yeah, we can agree it's a square. And that is a square length it's a square with side length of C. So it's plus a square. That's a square. Square with side length C. And again, marker, terrible idea. With side C. So the area of that square is going to be C squared. So now the area of the whole thing is going to be 4 1/2 ABs and a C squared. So let's look at this a little bit differently. So if I have 4 1/2 ABs, but if I have 4 $half, how much money is 4 $half worth? It's worth $2. So I have 2 ABs plus C squared. So there's one expression for the area, and there's the other. And there's this method of proving things in math where if you make 2 different things that represent the same end quantity, then those 2 pieces have to be the same. I forgot what it's called. It's some fancy word I never understood in college. But really, I made 2 different expressions for this big square. I used this, a plus b squared, to get this black thing here. And then I made this beautiful pink and purple diagram, which is the same square, and I wrote this. So I know that a squared plus 2ab plus b squared has to be the same as 2ab plus c squared. Now when we solve the equations, we like to simplify things. And on both sides of my equation, I notice I have a 2ab. So I'm going to subtract that. And what am I going to be left with? Hopefully a familiar looking equation. I'm left with a squared plus b squared equals c squared. And holy guacamole, isn't that cool? Because that's the Pythagorean theorem. And that's my right triangle, with A and B as legs and C as the hypotenuse. So this whole lesson's going to assume that you remember the Pythagorean theorem, which you don't have to. If you do remember, it's great. If you don't, it doesn't really matter. But it will make this lesson a whole lot easier if you do remember it. And if you don't, it's not a big deal. I'm not grading today's assignment, but it is a really fun thing to look at, and I wish we were in class to do it together because it'd be so much more fun. But we'll do one more little thing with Pythagorean theorem, And then now that you've proved it, and then you will have your quick exit slip. All right? Okay, so we are going to keep talking about the Pythagorean theorem, and we're going to talk about something called, a Pythagorean triple. So a Pythagorean triple is just a set of 3 integers, so whole numbers, no decimals, no crazy square roots, such that a squared plus b squared equals c squared. So it's 3 whole numbers that form sides of a right triangle. So the example, the 3, 4, 5 right triangle is a Pythagorean triple because 3 squared, 9, plus 4 squared, 16, equals 5 squared, or 25. And these are actually surprisingly uncommon. There are not that many. Okay, well, technically there's an infinite number, but there's not that many with small number side lengths. It very quickly gets into very high numbers and hundreds and thousands and stuff like that. So in terms of things that are infinite, it's quite a small subset. Anyway, so some guy named Euclid, who you might have heard of, made a formula that can generate side lengths that form a right triangle. And what we're going to do today is we're going to prove that that formula works. So whether or not you understand anything I just said, we can still prove that that formula works. So here's the steps. And we're going to pick numbers along with me. So step 1, we're going to pick any 2 positive whole numbers. And just for the sake of doing decent math, you can pick relatively smallish numbers. Call the bigger one m, so the bigger number has to be m, that's important. And the smaller number has to be n. So I'm going to go ahead and just pick a couple of random numbers. I'm going to let m be like 8. And I'm going to let n be 5. So 8 and 5, those are pretty reasonable. All right. So now, just a reminder, in a right triangle, we call the side lengths the legs and the hypotenuse. So if A and B are the legs, meaning they're the 2 shorter sides that form the right angle, they make that nice 90-degree angle, and we call C the hypotenuse, so that diagonal side opposite the right angle. C is always the bigger side, remember, if you've forgotten. The hypotenuse is always larger. Then we're going to calculate each of our side lengths from m and n. So if I let m be 8 and n is 5, those aren't our side lengths. We'll have to calculate them from there. So we're going to let a be m squared minus n squared. B is going to be 2 times m times n. And then c is going to be m squared plus n squared. So we're going to take a minute and just calculate what a, b, and c all would have to be based on this rule. So go ahead and try that. Okay, so I have done my math, and I found that m squared minus n squared, so 8 squared is 64, 5 squared is 25, 64 minus 25 gets me 39. So my side length A is 39. And then 2mn, 2 times 8 times 5 gets me 80. So one of my other legs is 80. And then C, m squared plus n squared, so 8 squared plus 5 squared gets me 64 and 25, which gets me 89. So my hypotenuse on my longer side is 89. So that's cool. I did some random math. Now I want to prove, in fact, does, in this case, does a squared plus b squared equals c squared? Like, does that actually work? So we're going to get my nice Desmos calculator out here, and I'm going to see if this in fact does work. So I'm just going to go ahead and I'm just going to take a picture of my computer. You can see my home computer now because this is the one that's in front of me. So I'm going to do, let's see, can we see my screen? Yeah, cool. So we're going to do 39 squared, and then 80 squared, and then 89 squared. And I'm going to see if a squared, 1521, plus b squared, 6,400, gets me c squared, and it does. Those first 2 numbers add to get me that third number. So that's cool. Like, we picked these random numbers and it worked. But we're going to prove how exactly this works. There's my work computer. Okay, so we're gonna go ahead and we're gonna see how this works. And the math involved isn't too crazy once you know what to do. So really, we wanna see what happens when we square all these quantities. And by squaring the quantities, I mean squaring m squared minus n squared, and squaring 2mn, and squaring m squared plus n squared. All right, because I want to see what in fact is a squared, b squared, and c squared. So I'm going to see over here, I'm going to figure out what is a squared. And a squared is m squared minus n squared squared. Oops. Oh no. And then b squared is 2mn squared. And then I want to see if those two things add together to get me c squared, which it will, because otherwise I wouldn't be doing this. So, I'll do all the math with you. Don't worry, just follow along. You don't have to repeat this. This will not be a test question, because you don't have tests anymore. I'm not going to see you for the rest of the year. Sorry, so sad. Okay, so now we're going to do m squared minus n squared times m squared minus n squared. So let's see, m squared times m squared is m to the fourth. M squared minus n squared is minus m squared n squared. N squared times m squared is minus m squared n squared. Please don't be alarmed by all the squares and quarters and stuff. It's just numbers. Don't worry about it. All right. And then negative n squared times negative n squared is going to be a positive n to the fourth. So now I'm going to simplify this, and I will end up with minus 2 m squared n squared, because I have minus m squared n squared and a minus m squared n squared. So it's like a negative 1 out here and a negative 1 out here makes a total of negative 2. All right, so I've really got m to the fourth minus 2 m squared n squared plus n to the fourth. All right, try not to lose me. I know it's weird, but we're doing it. You're doing good. Okay. So then I have 2 mn squared. And really that's just 2mn times 2mn. And so we just multiply across, so that's 4m squared n squared. Okay, so we got that. And we want to see if all that is equal to m squared plus n squared. So we're going to FOIL this out. I know, I really hate in math when there's no numbers. I really do get it. But it's just so cool, the ending. So m squared times m squared is again m to the fourth. M squared times n squared is m squared n squared. N squared m squared is m squared n squared. And n squared times n squared is n to the fourth. All right, so again, now I have a plus m squared n squared and a plus m squared n squared. So that turns into a 2m squared n squared, of course. I mean, why wouldn't it? There's one over here, there's one there, so I gotta combine them to make 2. Plus n to the fourth, and then m to the fourth plus. So all these things are equal. Okay. I'll have to turn my phone sideways for this, maybe. Yeah, hold on. Okay, so we're down here. We have all this junk. So basically, we want to see if this whole left side over here equals that whole right side over there. So on the left side and right side, notice I'm going to just cut off things that are the same on both sides. So I notice, here's my equal sign. So that's my border. All right, that's my divider. So I have an m to the fourth over here, and an m to the fourth over here. We're just going to sort of get rid of those. So the same thing on both sides. All right. And here I have an n to the fourth. And I have one over here too. So now I'm left with 2, oh geez, at least be neat, Mr. Roboto, m squared n squareds. On the right, I have that. I have a 4 m squared n squared. And I have a minus 2 m squared n squared. So really I have negative 2 of those plus 4 of those equals 2 of those. And if I combine those two like terms, I get 2 m squared n squared, which is the same exact thing on both sides. So yes, they are in fact equal. So, really, really messy math. But we proved that this Pythagorean triple formula works, which is super cool. And, okay, it might actually be cool. But you can do some fun things like making your own Pythagorean triples. You can use those rules to make your own right triangle side lengths, which is something I do when I'm making worksheets sometimes. So that's why I can come up with numbers so quickly for side lengths of right triangles. All right, so we just used what we learned in the past month or so for some really advanced provings. You followed along, you did great. Answer my couple exit slip questions, and you're great. Thanks for watching.